Hello students, let us discuss coordination number in the coordination compounds. Let us first define the coordination number. It is the total number of ligands attached to the central metal atom through coordinate bonds, or the number of atoms of the ligand attached to the same central atom. This can be better explained through an example. Let us take some examples here. Here, according to the definition, it is the total number of ligands attached to the central metal atom through a coordinate bond. So, when you take the first case in this, the nickel is the central metal atom. So, 4CO, CO is the ligand here, that is 4CO is attached through the nickel, that is through a coordinate covalent bond. So, we can say that the coordination number here it is 4. And in the case of this example, here also the central metal atom, it is we can say that 4OH are the ligands which is attached to the central metal atom. So the coordination number becomes 4. So we can say that in the first two examples, because only one type of ligand is present in these molecules, that is in the complexes. So here the coordination number, which is represented in short Cn, is 4 for both the complexes. But when you look at the other two complexes, this complex is heteroleptic because you can see that 3 different type of ligands are present, that is NH3, 4 NH3 are there, because here you can see 4 NH3, 1 water is the ligand and 1 Cl is there. So total how much it is equal to 6. So we can say that the coordination number for this is 6. What about the next one? In the next one here 2 Cl are there. So 2 plus, and how many En are there here? 2 En are there. But 1 En can form, that is ethylene diamine. 1 ethylene diamine can form 2 coordinate covalent bond with the central metal atom or the ion, because it is a bidentate ligand. So we can say that if 1 En can form 2 coordinate covalent bond, then 2 En can form 2 into 2, that is 4 coordinate covalent bond it can form. So that is total is equal to 6. So the coordination number for these two will be equal to 6. So the reason here, because En is a bidentate ligand, so you have to multiply with 2 with the number of En present. So that can be explained. The coordination number is different from the ligand. In some cases, the coordination number is exactly equal to the number of ligand. Like in the first case, NH3, 6, that is 6 NH3 are there, as you can see in the formula. So that means in this case, since NH3 is a monodentate ligand, so we can say that in this case the coordination number is equal to the number of ligand. In the second case also you can find out here the ligand is NH3. One NH3 can form only one coordinate covalent bond with the central metal atom or the ion. So that means 2 can form 2 coordinate bonds. So the coordination number is 2 here and ligand is also 2 in the second complex. But in the case of third complex where the ligand is En, we know that En, that is ethylene diamine, is a bidentate ligand. It can form 2 coordinate covalent bond with the central metal ion. So that means the 3 En can form total how many number of bond? That is a coordinate covalent bond. It can form 6 coordinate covalent bond. So we can say that it have a coordination number 6. But the number of ligand here it is 3. Why? Because En 3 times. So that means only 3 ligand is present here. But each can form 2 coordinate bond with the metal atom or the ion. That's why we have to multiply the 2 with this 3, because 3 ligand is present, so that is equal to 6. So its a coordination number is equal to 6. So that means what is clear from these cases, that the coordination number is equal to the number of ligand in the case of monodentate ligand, but in the case of bidentate or polydentate ligand, the number of ligand is not equal to the coordination number. Therefore, in order to calculate the coordination number for a different complexes, it is necessary to remember whether the ligand is a unidentate, bidentate or polydentate. For example, if the ligand is a unidentate, in that case you have to multiply the number of ligand with 1, and if it is bidentate ligand, then it is necessary to multiply the number of ligand with 2, and if it is a polydentate ligand like EDTA, it is necessary to multiply with 6 with the number of ligand present in that. Then only we will come up with the correct coordination number. So that we need to remember 1, 2, 6 number for these examples. That is, multiply with 1 for the unidentate, multiply with 2 for bidentate, and multiply with 6 for the EDTA. So we'll be getting the correct coordination number. Coordination number is important to find out or to predict the geometry of the complexes, as if the coordination number is 2, then its geometry is linear. If the coordination number is 4, it can be either tetrahedral or square planar. If the coordination number is 5, its geometry is either trigonal bipyramidal or square pyramidal. If the coordination number is 6, then it is having the octahedral geometry. So the geometry of the complexes can be identified by its coordination number. So that we'll be discussing more in detail when we'll be discussing the structure of coordination compounds. So this is all about this video. Have a nice day.